Hello, sir.
I'm sorry. I think I was not audible. Nah?
हाँ sir.
Now I'm audible.
हाँ.
Okay. I have to repeat it once again. Okay. So, good morning, friends. Today we are going to study injection mold design process. So, this is unit number 6. The outcome or contents of this are we are going to see what is the different cooling control or temperature control systems. Then we are going to also see the ejector systems, different types of ejector mechanisms, and then injection mold design, which is part of case study in the practicals, which will not be asked in the theory examination if exam will be subjective. Okay, but even it will not be asked in the examination. That design procedure you must know. So this is these are only small content of this unit. What is outcome? The outcome of this unit is at the end of this unit, at the end of this chapter, students will be able to design the injection for given plastic component. I repeat once again, at the end of this unit, students will be able to design the injection mold for given plastic component. Very important thing. Whatever mold you are going to design, you must know what is the process which you are going to use. Means component drawing is given and directly you start designing the mold without knowing or without deciding the process. It will never happen because extrusion molding molds are different. Injection molding molds are different. Compression molding molds are different. Rotational molding molds are different. So how important it is, see, before designing the mold, you must know for what process you are going to employ for it. Because everywhere cooling system and other systems are different. Now in this chapter, so at the end of this chapter, you will be able to design the injection mold. This will be the outcome. Now, what is the first bit of this chapter? The first bit concentrating on temperature control in the injection molding. Temperature control in the injection mold. So I repeat one statement. Earlier I made this statement that almost 70% to 80% of the cycle time is used for cooling. So what kind of temperature you are going to control here? Remember what type of injection molds you are going to use. Maybe 2 plate, 3 plate, whatever may be. You are going to inject the plastic material with the help of injection mechanism. That plastic material is hot. Temperature may be around 200 degrees Celsius. That plasticized the plastic will go in the mold, and mold is made up of metal. So due to chilling effect, it will start solidifying because heat of that plastic will be absorbed by that metallic mold walls. Once that metallic mold walls will absorb the heat, so for improving the efficiency of heat extraction, water circulation will be carried out. How water is circulated? Some channels and grooves are provided or made in that mold. These are called as cooling circuits, which is part of 7th chapter. Okay, so small content, the 6th and 7th chapter is split in that way. So that we are going to see in 7th chapter what kind of circuits are provided. So I want to say that cooling will be carried out and then heat will be dissipated. So what a heat is extracted by the mold, it will be taken away from the mold by water, and water will go out. Once again fresh water will come in. Again whatever heat is extracted by the mold wall will be again taken by the water, and water will take it away. Means water will enter with less temperature and exit with more temperature. Means for example, it may enter with 20 degrees Celsius in the mold, and when it will come out of the mold, it may be 80 degree or 60 degree, whatever may be. One important thing, point to be noted here, there is no direct contact of product with the water. Remember this. There is no direct contact of plastic product with the water in case of injection mold, whereas in extrusion mold, where the product is coming out through the nozzle, it is cooled by air or water. There is a direct contact of water with the product. This is the main difference in extrusion molding and injection molding. Now, fast cooling, you can cool it very fast. If you want to increase the rate of production, you have to cool fast. So I want to say that fast cooling will increase the rate of production, but there may be chances of rappage and distortion. So that's why cooling, uniform cooling, when optimum time of cooling is important, and accordingly the cooling circuits are designed. And mold temperature is playing very important role. Mold temperature is playing very important role here, and your water which you are going to circulate, that is controlling your mold temperature. So mold temperature have which effect? Shrinkage behavior of the product will become controlled because of mold temperature. Then your mechanical properties, surface quality, flow length of thin wall, cycle time, all these things are controlled, and hence the required cooling time increases rapidly with wall thickness, because if the components thickness, see this product, it is having this wall thickness. If the wall thickness will be larger, then cooling time also will be different, because this is bad conductor of heat. You have to circulate water more and more so that mold will absorb the heat. It will take more time to extract the heat from center of the plastic part to the surface of plastic part. That's why higher the thickness of wall of the product, more time is required for cooling of it. So this is a small bit, maybe asked for 3 marks. Just write 2-3 lines regarding it. The cooling condition in the mold, affects the cycle time. Part dimension. Cooling condition in the mold affect the cycle time, part dimension, surface finish, and shrinkage. Cooling conditions affect cycle time, part dimension, surface finish, and shrinkage. Next line, about 70 to 80% of cycle time will be required for cooling. About 70 to 80% of cycle time will be required for cooling. Full stop. Uniform cooling improves part quality. Faster cooling will increase the rate of production. And uniform cooling will increase the quality of product. Okay. Mold temperature has effect on following points. First, shrinkage. Second, mechanical properties. Then third, surface finish of the product. Shrinkage, second, mechanical properties, third, surface finish of the product. Then cycle time. Then last sentence, cooling time increases with wall thickness. Cooling time increases with wall thickness. Now next important bit is ejector system. Or ejection. Pay attention now. So how the cooling is important, in the same way ejection is also equally important, because it works on removal of the component after solidification. So first part is played by cooling. Later on, after solidification and cooling, that part should be taken out. Then there should be proper ejection mechanism, which is allowing the product to move fast. Now there are two halves. This is one and two halves of the mold if you consider reciprocating horizontal motion. One half is fixed and another half is moving. I repeat, one half of the mold is fixed and another half is moving. The part which is fixed, here the nozzle arrangements are there in this way. The part which is fixed, here is the nozzle arrangement. Okay, through this nozzle, the molten plastic will come inside the mold. This is nozzle, injection mechanism. Okay, injection mechanism. And now ejection system. Injection means allowing plastic to go inside the mold, and ejection means removal of the solidified product. So injection mechanism is fixed to the fixed half. I repeat once again, injection mechanism is fitted to the fixed half and ejection mechanism is fitted to the movable half. I hope you are getting my point. Injection mechanism, that is injection mechanism, machine, nozzle, is fitted to the fixed half because you can't move the machine. But ejection mechanism is fitted in the movable half. So once this part will come backside, then you can remove your component. Depends upon it. This I said majoritarily. Sometimes there may be change. Depends upon the availability, because you can't move the that injection machine. So if there is a certain arrangement, you can see this. I told only simple case, but there are certain core plates are there. It is not so easy. So what I am saying, it includes just, there is no only simple mechanism of ejector pin, but there are many core plates. There are 2-3 plates, one moving from top, some may be moving from bottom, or making or arranging the cores to create the holes in the plastic part. So it is a very complicated mechanism. So simply remember, it is in the movable half. And there are number of mechanisms. You have only learned the pin mechanism, but there are number of ejection systems. One by one you can write. Pin system, pin ejection, then sleeve ejection, then wall ejection, then air ejection, and stripper plate ejection. Pin ejection, sleeve ejection, wall ejection, air ejection, and stripper plate ejection. I done this. So now let us see pin ejection. Now see here. I already told you in the previous class, pin doesn't mean pin of just hairpin or a small diameter wire. Like it may, we are calling it as a pin. It is actually a rod. See this pin. Okay, so such pins or rods are used. Now we have also studied that depending upon the contour of the product, the end shape of the pin is adjusted. If edge is flat, pin surface will also be flat. If edge is convex, pin will be concave. If edge is concave, pin will be convex. And if has different contour, pin will also have different contour. This part we have studied in previous chapters. Now, what will be the diameter of pin? Yesterday we have seen the concept diameter of pin. Usually, length of pin is taken as 5 times diameter of pin, and then diameter of pin will be approximately taken as wall thickness. So what will happen if it will be less than wall thickness? What will happen if it will be more than wall thickness? So there are 3 cases: pin diameter equal to wall thickness, pin diameter less than wall thickness, pin diameter more than wall thickness. So before that, see, if we draw the product, you can draw this figure. Draw this figure. Ejector pins. We are talking about diameter of ejector pin. Okay. So usually it is taken as equal to wall thickness. What will happen? It will be less, and there are 3 cases. See, there are 3 cases. Case number 1, diameter of pin equal to wall thickness. And this case is always accepted. Diameter of pin is approximately equal to wall thickness. And this case is accepted always. Then diameter of pin less than wall thickness. Third, diameter of pin greater than wall thickness. And this is wall thickness. Draw it fast. Diameter of pin approximately equal to wall thickness. This case is always accepted because it will give good support to the pins and you can easily remove the solidified product outside the mold. What will happen if diameter of pin is very less than wall thickness? You can see the case number 2. If diameter of pin is very less than wall thickness, there may be chances of piercing of that pin into the product. If you look at this figure, you may find that that pin may get penetrate inside the product because product is tightly packed. It is get stick to the wall of mold, and if it will stick more and you find there is a more pressure of the pin, you may find that, see the pin is at back side, the pin may come out in this way. The pin may come out in this way or it may penetrate inside the product, which will not be accepted. If you use larger size pin, if you use larger size pin for small wall thickness, it is a loss of efficiency. It is a loss of efficiency. For example, you want just 1 liter of water or half liter of water, and if you, for bringing that half liter of water, you can take mug, small mug, but instead of that, if you take big bucket to carry that half liter water, it is loss of efficiency. Same way, same concept here. If you use larger size pin, there is a loss of efficiency of operating that mechanism for the small component. So that's why case number 1 is acceptable. Case number 1 is acceptable. So now, first type pin ejection we have studied. I hope you have noted it down in notebook. You can take screenshot also. Now, friends, if your product is like pipe shape, just imagine it is a hollow cylinder with minimum wall thickness. I repeat once again, if your product is hollow, that is like pipe or hollow cylinder with minimum wall thickness, it is very difficult to locate that pins on the edge of pipe or edge of product, and there may be cause slippage of it. That's why different ejection mechanism is employed. That mechanism is called as sleeve ejection, which will fit in that wall and which can take that product out. Sleeves are foldable. Initially, it is at some minimum height, and as soon as the mechanism operates, it increases its height. It is similar to your antenna, extended antennas. Old days, some mobile were also having, and you might have seen in radios and other things. If you extend that, antenna will come out and length of that antenna go on increasing. So that is sleeve mechanism. Initially, so pipe in, pipe in, pipe in, pipe in that way. So if you take, you can adjust the length by pulling it out. So it is similar mechanism. So it is operated by some mechanism and that will easily fit, depends upon diameter of that hollow cylinder. It will fit there. Some of the length may go inside, no problem. There is no question of penetration. It may be part of hollow length and then it will take that product out. So sleeve ejection system is used for some typical components where you can't locate the pins, and if you try to locate the pin may slip and you cannot get your product properly holded and supported by the ejection mechanism. So to avoid it, depends upon the size and shape of the component, ejection mechanism is also changed and it is made as a sleeve mechanism. So you can write down this one or two statements. When product is with hollow shape, in bracket hollow cylinder, like hollow cylinder, comma, the pins cannot be fitted at the thin wall. Pins cannot be fitted at the thin wall. As area of face is very small. As area of face is very small. Full stop. For such cases, sleeve ejection system plays important role. Sleeves are with adjustable length. Sleeves are with adjustable length. And can be operated as per the requirement. Draw the figure. Sleeve ejection. So friends, in today's class, what we have started with injection mold design, where the temperature control was covered as the first bit, and second, ejection system. There are different types of ejection system, out of which we have studied pin ejection system and sleeve ejection system. Okay, I hope you have noted it down. Short note may be asked for 3 marks. Okay, so this unit number 6 of injection mold design, whatever part we have covered today, here we are going to stop, and remaining types of the ejection mechanism and other system, which will be covered in the next class. Okay, we will stop here. Thank you.